We can start.
Okay, let's start. So I just came back from 2 weeks vacation, so I'm still a bit rusty. But if I recall correctly, when we interrupted the class, we gave some assignments, right? Projects. Can somebody please remind me what the project was? Robertino, do you remember?
It was the week. Yes, sorry.
No, sorry.
Yes,
Go ahead.
sorry. It was the week 1 project. It was a series of increasingly difficult challenges that using I/O and testing. So
I see.
yes, so there were like 3 or 4 like small mini projects. Not, I mean, initially we wanted to do the chat server chat, but it was too advanced, so we used that one. Yeah.
I see. Okay. And I mean, what's the plan with that? To give people some time to showcase their solutions, or do we do that offline? Or
I mean, it was the same process as all the other homeworks. So they had the link and they could submit it. But I mean, it would be cool if someone wants to showcase or maybe openly talk about difficulties or things that they figure out on the way.
Right. So maybe seeing as we are all a bit unprepared now, maybe we can postpone that to Wednesday or Friday. So so people submitted something as well, right? So maybe also if people would like to showcase what they did, maybe they can do that then, like on Wednesday or Friday. And then they also have some time to prepare.
Yes, and maybe if you're unsure, if you want to do it, maybe you can talk to us in private chat, and
Sure.
we can just talk it out to see what you want to talk about, and we can just coach you a bit.
Yes, of course we should. I mean, it's a bit unfortunate because I think you were also on vacation, right? Or had some days off?
Yes, I just came back, but still, like anyone wants to present, they can just DM me. They all have my Telegram, and I can coach you. Yeah.
Yes, so yeah, we also hadn't had a chance to coordinate yet, because we were both on vacation. Right, so let's coordinate like soon, and then we can decide how to proceed with that. Okay, and I think Karina is sick, unfortunately, and it's a public holiday in Mexico. So
the stars aligned.
But Antonio is here, so in spite of the public holiday. Right. Okay. Right. So after this break, I mean, you have now gotten a introduction, quite a thorough introduction into Haskell, and we managed to do the monad lecture before the break. And monads, as I mentioned when I gave the lecture, are often considered like the main stumbling block in learning Haskell. So once you have mastered monads, it's basically downhill from there. So that's actually a natural stopping point for like an introductory course into Haskell. And in the past, when we did these courses, we went much deeper with Haskell. And one of the reasons was because, I mean, part of the goal of these courses was to recruit Haskell developers for IOG, because most of the IOG software is written in Haskell. And of course, apart from that, I like passionately believe that Haskell is a very valuable skill to have, even if you don't end up being a professional Haskell developer, just because it gives you this unique new perspective on programming. And the third reason was that once smart contract became available on Cardano with the Alonzo hard fork, you had to use Haskell to actually write smart contracts. However, that is no longer true, because I mean, now it's like, is it 2.5 years afterwards, after Alonzo? So there have been lots of developments. So for example, there have been other programming languages been designed that target Pluto's core, the sort of like the assembly language of Cardano smart contracts. That are, I mean, that are also functionally normally, although I think there's also one that's like Python. But nevertheless, it means that it's no longer strictly necessary to write Haskell if all you're interested in is writing dApps on Cardano or building projects on Cardano. I mean, I think it's still valuable to do Haskell. And I mean, I personally, for my projects, I always pick Haskell, but it's no longer a strict requirement. So we decided that we should now shift gears a bit and not continue going much deeper into Haskell, but instead concentrate on actual Cardano development, writing dApps or smart contracts primarily on Cardano. And not using Haskell, but instead using a new language that's called Icon, which is also functional. So all you have learned about functional programming when you got this introduction to Haskell will definitely help you. But it's much simpler than Haskell, I think. So if all you're interested in is writing Cardano dApps, then that is sufficient. So we want to like start teaching Icon now for the next couple of lectures, and then, I mean, most importantly, see as many examples as possible of smart contracts. But today I won't start with Icon, and instead just explain how smart contracts on Cardano work in principle, so the theory behind it or high level, because that's completely independent on which programming language you use. And that's the idea of the so-called UTXO model, the extended unspent transaction output model. I do believe there are some slides that Karina prepared. I'm not sure whether I should use them. I hadn't had a chance to look at them. Maybe, Robertino, you had a look, right?
Yes. Yes, they are in the teacher's repo.
Okay.
And maybe you can start. I mean, we have 2 slides saying like cryptography demo to show like designing the demo that you made, and then EUTXO. And then it's just like 6 or 7 slides about Aiken itself.
Okay. So I think maybe then we do the first 2 things today, right?
Yeah, I think it's better. Yeah.
Okay. This demo, didn't I do that already in the very first lecture? But I'm happy to do it again. So yeah, let me.
Yes, I think you did, but maybe yes, maybe EUTXO and just a quick overview. I'm not sure however you want to play.
Yeah, sure. Let's see. Let me first.
It was many weeks ago as well.
Yes. Let me just find the slides quickly. Must pull obviously. That's a bit strange because I have like lecture 09 and then the next one is 22, Icon intro.
Yes, it's that one because
So what is 10 to 21?
It was the advanced part of, yeah.
I see. Okay. Okay. Right. Let me just open that and then I can share my screen. Let's go. Give me a second. I can't. If for some reason something happened with my last upgrade. I mean, I'm using Arch Linux and that has this rolling release thing. And unfortunately, sometimes something just breaks and now my PDF viewer doesn't work, it seems. So I need some time to figure that out. So I think I don't use the slides today and then until Wednesday I figured that out. But it's fine. So do you think, Robertino, I should do this cryptography demo again?
If you think, I mean, maybe we could do it quickly just to make sure that everyone's on the same page.
Yeah, let's do that. Let's just find it.
Also, maybe you could use Firefox or Chrome to open the PDFs.
True. I can try that as well. Good idea. Let's second. Stupid. I mean, normally I love my Arch Linux, but at times like this, it's really annoying that things just break.
I can share them if you want.
Let me just try whether it works in Chrome. If not, then you
okay.
then ask you to share. Good work, I suppose. That doesn't look too bad. It's just far too small. Right. Okay. Yeah. Let me share. I have it now in Chrome.
Awesome.
Thanks for the hint. Yeah.
Sure, no problem. Also, like these slides, the actual slides that you render, the steps of the UTXO, they are not part of the new ones.
Right.
Of the yes.
Let's see. I mean, this looks more like an introduction to Icon.
Yes.
Okay. Right. This one. Oh yeah. Okay. Fine. Okay. There's not really much to see, but okay. Just give me 1 second to find my this crypto demo. I think it's here. Okay, it seems to work. Bless. Right. Okay, so I think this is a repetition of the very first or second lecture, but I think it makes sense to do this again because now we are concentrating on actual blockchain, or rather Cardano. And I mean, for me, it's always important to stress the fact that it's important to have the big picture. I mean, that's why I like this image of blockchain being a ledger in the sky, or you can also say it's a distributed, decentralized, write-only database. It's one way to look at it. But of course, in order to actually, so that's important to keep in mind what the abstraction is that we are actually working with. So it's like a public thing, decentralized. Everybody has access. There's no censorship. And what is this thing that everybody has access to without censorship? It's in principle a database that people can write to. You can't edit stuff after it's been written, and you can't delete it. So that's like blockchain in general. And then something like Cardano, cryptocurrency, it's not arbitrary things you write. It's mostly primarily financial transactions. So Alice sending funds to Bob. But that's this abstraction. And I mean, that's very useful for a lot of things. I mean, even without smart contracts, it's already useful to have this system of basically digital money that you can freely access from everywhere in the world. But it becomes much more powerful in the presence of smart contracts, as we will see in the coming weeks. But nevertheless, I mean, that's important to understand what it is. But then, of course, if you wonder how it's actually implemented, then it's obviously mathematics, and in particular cryptography. So it's basically two main ingredients, and I said that in the very first lecture already. I mean, there's like the small stuff to make the transactions itself secure, and that relies heavily on cryptography. And there, the two main ingredients are hashing and digital signatures. And then the missing ingredient, which is also the reason that we only got Bitcoin in 2008 and not in the mid-70s of the last century, when these digital signatures were invented, is the consensus. So that is the algorithm that makes it possible to coordinate thousands of nodes, of copies of the data on the blockchain across the whole world in a decentralized manner. So without a central authority, as long as sufficiently many people follow the protocol, it's a very robust and secure system with certain guarantees, like that everybody more or less has the same copy of the blockchain. I say more or less because, like, at the end towards the present, it frizzles a bit, But if you go far back in the past, like an hour or a day, then everybody agrees in the whole world about the state of the world, the state of the blockchain. So there's no disagreement about, in particular, how much money somebody owns. And that, I mean, to make that possible, you need consensus algorithm. And as I explained in the very first lecture, in case of Cardano, we use proof of stake, which is like 1,000,000-fold more energy efficient than Bitcoin or Ethereum, for example. Okay, but like at the very foundations of everything is cryptography, and in particular, these two things, hashing and digital signatures. So hashing is like a fingerprint. You can have arbitrarily large data and reduce it to a hash, which is a fixed length byte string. And I mean, mathematically, because I'm a mathematician, I always have to say that. I mean, a hash function is basically a map in the sense of mathematics from the set of arbitrary byte strings, so byte strings of arbitrary length, to the set of byte strings of a fixed length. And there are only finitely many byte strings of a fixed length. So this target space, the domain, or the codomain, I always forget what's codomain and what's domain. Anyway, the target is finite, but the source, like byte strings of arbitrary length, are infinite. That's an infinite set. There are infinitely many byte strings if you don't restrict the length. So if you have a map from an infinite set to a finite set, then that's what mathematicians call the so-called pigeonhole principle. So if you have more pigeons than you have pigeonholes, and each pigeon sits in a pigeonhole, then there's at least one pigeonhole with more than one pigeon in it. So if you have 10 pigeons and 8 holes, and all the pigeons sit in a hole, then there must be one of the 8 holes at least with more than one pigeon. That's one of those things that's glaringly obvious for normal people, but of course mathematicians have to prove these things. But anyway, and the same applies in particular for infinite, if the one set is even infinite, which means that if you have this hash function from infinite set to a finite set, then obviously there must be many byte strings that have the same hash, even infinitely many. Nevertheless, the cool thing about hash functions is that even though in principle you know that there are like byte strings that have the same hash, in practice it should be almost impossible or practically impossible to find such documents, so such byte strings. So it should be almost impossible to find two different byte strings that have the same hash. And I mean, that's quite amazing and surprising, almost a miracle, I think, that there are functions like that, but there are. And those are called hashing functions or cryptographically secure hashing functions. And okay, so the first demo is about hashing, and this is just supposed to demonstrate some of the features. So, I mean, the input text can be an arbitrary byte string, and in this case, it's an arbitrary string. So, for example, I'll Haskell. Right. So the way it works is you have some arbitrary data. Then first you need to serialize it to a byte string because, strictly speaking, hash functions work on byte strings, not on arbitrary stuff. So you get this byte string. I suppose I forgot, but I think it's UTF-8 encoded or maybe ASCII encoded. I think UTF-8. So you get this byte string. And then the hashing function is applied to this byte string and you get this hash. In this example, in this demo, it's the SHA-256 hashing algorithm. The 256 means the output is hashed byte strings of length 256 bits, which is 32 bytes. So there should be 64 hexadecimal characters here. So the first thing to note is that the input can have arbitrary length, but the output always has this fixed length, in this example, 32 bytes. And so if I make this longer, and if you keep an eye on the output, then you see that this always keeps its length, even though the input text becomes longer. Right, so that's the first observation. And the second observation that you can see in this demo is if I make a minuscule change to the input text, the output changes unpredictably and dramatically. So if I remove this apostrophe, this quote here, this apostrophe, then the resulting hash is completely different. So it's not what mathematicians would call a continuous function. Continuous means small wiggling, small changes to the input result in small changes to the output. So a hashing function is metaphorically not continuous in that sense. So if I do tiny changes, the output changes dramatically. And I mean, that means if you have the hash of something, okay. And even though, so the point is, even though we know from the pigeonhole principle that there are like infinitely many input tags that would result in this hash probably, it should be practically impossible, even if you have all the computing power in the world and millions of years of time, to actually find another string that has exactly the same hash. So that means if you know the hash, then in principle, I mean, you don't know the input text, but if somebody gives you the input text, then you can check that the hash is this, and then you can be almost 100% sure that that was actually the input text. Because for somebody to find a different input text that has the same hash, that should be practically impossible. And that makes things possible, like, I mean, in the context of finance, if I have like money, something like this, and then this is the hash. And if now somebody tried to manipulate the original message, for example, by adding a 0, then we would get a completely different unrelated hash. That means it's basically impossible to manipulate the input or pretend that a different input led to this hash. That's also, I mean, it's not only, I mean, it's a very useful thing to have anyway, not just in the context of blockchains. So for example, I mean, one common use case is fingerprints for downloads. So if you download something from some site, often they give you the hash of the file you're downloading. And then when you download it, you can compare, I mean, you can hash the result that you downloaded compared to what they say. And if it's the same, then you can be reasonably sure that there was no transmission error during download, or that nobody tried to give you like a wrong document or tampered with it. So that's often used when you download sensitive software, for example, or sensitive data, that people give you the hash of what you are downloading as a fingerprint. Right, so that's hashing. And the second fundamental ingredient for like blockchain technology is digital signatures. And there are like lots and lots and lots of different algorithms for digital signatures. And some of them are these public-private key signature schemes. And they work by somebody that wants to participate in this scheme first needs to generate a so-called key pair. So this in this demo can do this. So it gives you a private key and a public key. And those are just byte strings. And normally or always it's possible to give the private key to compute the public key. So the private key is enough to also have the public key, but not the other way around. The public key doesn't allow you to compute the private key from it. That's again not true in the strictly mathematical sense, but in the practical sense. So again, you would need all the computers in the world for millions of years to actually figure out a private key corresponding to a public key. And the private key is called private and the public key is called public because you are supposed to keep the private key private and not tell anyone, whereas you can publish the public key. And then once you have that, you can use it to sign messages. So for example, again, this thing I sent 1,000 ADA Chocolatino. So like technically what you're signing is not the message directly, but the hash of the message. So that's another reason why hashing is important. So the way it works is first you take the message, then you hash it, and then you apply this digital signature scheme using your private key to get a signature. Signature has the same property as a hash in the sense that it's always fixed length. So if I add characters here, the signature each time changes dramatically. but the length stays fixed. Right, and then what can you do with the signature? Now somebody else can verify the signature. So if you give them the message and your public key, but not your private key, and the signature, then this digital signature algorithm allows you to verify. So you can verify that a given message or that a signature was the result of signing a given message with a private key that corresponds to the given public key. So just knowing the public key and the message and the signature, you can verify whether the owner of the corresponding private key signed this. And I mean, as we saw here on the left-hand side already, if I change the message, the signature also changes. And this is different to like what we are used to from signatures in everyday life. I mean, if you sign with pen on paper, then your signature is supposed to always look the same, more or less. I mean, obviously we're all humans, so it's not exactly the same, but it looks very similar. But the same obviously wouldn't work in a digital setting. If your signature was just like one byte string, then as soon as you have signed one document, somebody could just take this byte string and like reuse it for other documents. And it would be like laughably easy to forge your signature. So therefore, it's important that the message changes. So for example, now again, you can imagine that I write this, I sign it digitally, and now I give the message, my public key and my signature to Robertino, and he walks to my bank, like as a IOU, and then the bank checks my signature and pays him 1,000 ADA from my account. And the bank knows that it's legitimate because the signature is verified. So now the point is if Robertino now tries to cheat and he changes the message and the bank tries to verify, then it's invalid. And Robertino also doesn't, if he wants to cheat, also doesn't have the option to forge the signature because, that's practically impossible again from just knowing the public key. For me, with the private key, it's easy, but if you only know the public key, it's almost impossible. And that is used in blockchain because transactions and blocks are signed. So transactions, as we will see now in the next part, when we talk about the EUTXO model. But basically, if I send money to Robertino on the blockchain, then I have to sign that transaction. So if it's my money that's getting spent, then I have to sign it. And that means even if you forget about consensus and all that higher level stuff, transactions by themselves are secured by digital signatures. So no matter what, even if there's like whatever attacks on the blockchain, your money is always safe in this sense. So if you don't sign a transaction that allows the transfer of money from your account to somebody else's account, then no matter what, nobody can take your money. So that's like basic security on the level of transactions. And then, we talked about blockchain. What blocks is like pages in the book of these ledgers. So it's just a bundle of transactions. It doesn't have a deeper meaning, same as different editions of a book can contain the same text, but the pages may have a different size. So maybe one edition has more pages than another, even though the content of the book is the same. It's similar with blockchain. The blocks are not really important. It's not really important which transactions are in those, how they are bundled. What is important is that are the transactions themselves and their order, their sequence. So this, blocks are basically used for the same reason that you use pages in a book. 2,000 years ago, people wrote on long scrolls, and that was a bit impractical to handle because you have all these big scrolls, and if you want to read it, you have to like unroll it and roll it, and so it's much more practical to use a book with pages. And it's more or less the same with blockchain. There's no really deep reason why we need blocks. We could also have like individual transactions chained together in the right order. But anyway, these blocks, the consensus is all about who has the right to create the next block. And blocks, so somebody creates this block, bundles a couple of transactions together into a block and publishes this block on the blockchain. And those blocks are also signed using digital signatures, signed by the private key belonging to the public key of the block producer. So at least at those two points, signing transactions when you spend inputs and signing blocks, I mean, these digital signatures are used. And I think different blockchains use different digital signature schemes, but that's not really important. I mean, because they all have similar properties. So what I say here, I even forgot what algorithm this is. I suppose RSA, like the grandmother of all public key signature schemes. So various blockchains use different algorithms for the actual signing, but they all have the same property: public key, private key, and then the algorithm allows you to produce a signature and to verify a signature. And like mathematically, there are a lot of different algorithms, but they all have these same properties. So I think that's all I want to say about this. Are there any questions?
Not in the chat.
Okay, then I think I look for my UTXO video. Let me see. Do you by any chance have a link?
I mean, if you look it up inside YouTube, you'll find it easier, I think.
Yeah, that's probably better. Embarrassing. It's very cool. She sings Carmen. Anyway. Let's see.
Bluetooth Pioneer program.
Yeah.
I think so, yeah.
Right, I think that's fine. The iteration doesn't really matter, does it? I suppose I should use
Yeah,
it.
I think in the last one you added the thing that you already explained about the signing, but
okay.
the UTXO explanation was the same, I think.
Okay, so I can just use iteration 4?
Yeah, I think so.
Okay. Now I have to. No, I don't want that. Okay. Let's see. Blah, blah, blah. So I gave all that speech already. Is this only the intro?
No, it's just you are on the UTXO model. Oh,
yeah,
you
but
already went through
it's split into different. Ha! Look at that. Okay. Right. I was hoping that there was something on. Yeah, on accounting models. That's okay. This is that. I just gave you. Okay, must one more chapter. Right. Okay. Okay. Right. So now let's, after we have the cryptography out of the way, let's talk about the eUTXO model. And first we talk about the UTXO model, the unspent transaction output model. And that's the one that was pioneered by Bitcoin. So the very first blockchain, Bitcoin, used this model. And I mean, others like Ethereum don't. So Ethereum uses the so-called account-based model. I thought I had some slides somewhere about that as well, but I don't find them now. Anyway, so I just say it verbally. I mean, Ethereum works more like you would expect from a bank. So the participants have so-called accounts, and accounts have a balance. So for example, I could have 2000 ADA on my account. And if I want to send 100 ADA to Robertino, he also has an account, then a transaction would subtract 100 ADA from my account. So my balance changes from 2000 to 1900. And Robertino's balance changes from whatever he had before to 100 ADA more. So that's like, at least naively, I think the bank works. People have accounts have balances, and transferring money means subtracting an amount from one account and adding it to another account. That, however, is not how Bitcoin works, and it's also not how Cardano works. So Cardano, as I said, uses the so-called UTXO model, which stands for unspent transaction output model. And that is a bit more like, instead of like bank accounts, it's more like wallets with coins or notes, bank notes. But the analogy is not 100%, unfortunately. But the point is, so you can think of it like coins. So the current state of the blockchain in Ethereum, you can think of is a long list of accounts, or the people that have Ethereum accounts, and for each account a number, which is the balance. So that's the state of the Ethereum blockchain. I mean, it's not true, it's more complicated because of smart contracts, but as far as the transferring money part is concerned, that's close enough. And so in Ethereum, a transaction changes the state by modifying these balances. So, for example, I have, in the next step, I have less Ether and Robertino has more. So on UTXO blockchain, it's different. So there, the state is the set of UTXOs, which is the set of unspent transaction outputs. And you can think of it like a bunch of coins that belong to people. So at any given time on the Cardano blockchain or on Bitcoin, we know, okay, this money is available, these coins, and for each coin, we know to whom it belongs. So in this example that's on the screen now, we can think that there are two coins. One is worth 100 ADA and belongs to Alice, and one is worth 50 ADA and belongs to Bob. And where on Ethereum a transaction updates the state, I mean, it does that as well on Cardano, but on Ethereum, it basically in place updates balances. What happens on a UTXO blockchain is different. Nothing is modified in place. Instead, unspent, I mean, some of the coins that are unspent get spent, so are removed from the state, and new ones are created. So that's the only thing, principle that changes on a UTXO blockchain. So as an example, let's say we want, or Alice wants to send 10 ADA to Bob. So similar to, I mean, what would happen if you, I mean, if you think of coins, so you only have a banknote of $100, for example, in your wallet, and you want to pay $10 to Bob, or Alice wants to pay $10 to Bob. Then, I mean, you can't tear the banknote apart into two pieces, so one $10 piece and one $90 piece, and hand the smaller piece to Bob. I mean, you have to give him the full banknote, the whole thing. I mean, you can't split banknotes in half. So that's similar on a UTXO blockchain. So in this case, Alice would create a transaction, and the transaction is represented by this rectangle here. So transaction has inputs and outputs. And as input, Alice needs to will use coins that belong to her. So in this example, there is only one. She only has one coin, this 100 ADA coin. So she uses that as input. And then transaction can have outputs. So she wants to give 10 ADA to Bob, so she can create such an output. And this is where the analogy to actual coins and an actual wallet breaks down a bit, because in the transaction, basically she can split the inputs. So the transaction has now 100 ADA as input, and Alice can decide how to split those 100 ADA, to distribute those to different outputs. So if she wants to give 10 ADA to Bob, she can create an output 10 ADA to Bob, and then there are 90 ADA left, and she can create a so-called changed output of 90 ADA back to herself. So that's a very simple transaction, but I think a lot of, probably 90% or so of transactions on the Cardano blockchain, or the Bitcoin blockchain for that matter, do look like that. So one person wants to send some money to another person. So basically she takes one of her coins that belong to her, sends a part of that to that other person, and the change back to herself. So this is a transaction, a very simple transaction on Cardano. And the effect would be, I said before, the state of the Cardano blockchain is given by the set of UTXOs, unspent transaction outputs. So the old state was where the set consisted of 2 coins, 100 ADA belonging to Alice, 50 ADA belonging to Bob. And after the transaction, the state has changed. So the original 100 ADA coin has disappeared from this set, and 2 new coins have been created. The 90 ADA coin belonging to Alice, and the 10 ADA coin belonging to Bob. And that is, as I said, all that changes on the UTXO blockchain. So the coins themselves are not modified. Nothing is modified. I mean, the individual coins are not modified. What the transaction does is it spends existing ones and creates new ones. And I mean, it's called unspent transaction output. So, I mean, before the transaction, this 100 ADA coin belonging to Alice was unspent. And now this transaction spends it. So it removes it. It's no longer unspent. It's now spent. And for that, there are now 2 new unspent outputs. So that's like a basic, very basic transaction on the Cardano blockchain. And just see. Now a somewhat more complicated one, where the idea is that now Alice and Bob both want to send 55 ADA to Charlie. So in total, Charlie is supposed to get 110 ADA, but 55 of those are supposed to come from Alice, and 55 are supposed to come from Bob. So that's also possible on Cardano. So it's not just one, I mean, doesn't necessarily have to be one person that sends funds. It can be more than one, like in this example, Alice and Bob. So in this case, we get a more complicated transaction with 3 inputs. So Alice has no choice for her input, because at this point, she only owns 1 coin, this 90 ADA change output from the first transaction. So that's one of the inputs. And Bob also wants to pay 55 ADA, and he has 2 coins. He has this 10 ADA coin he just got from the first transaction, and he has the original 50 ADA coin. But each individual would be too small to pay 55, because both 10 and 50 are smaller than 55, obviously. So Bob has no choice. He has to use both of his coins as input. So we end up with the second transaction, which has 3 inputs. 1 coin belong to Alice and 2 belong to Bob. And then transactions can have more than 1 input. In this example, 3. And they can also have more than 1 or 2 outputs. In this example, 3. So in this example, we have 3 outputs. 1 is the 110 ADA going to Charlie, so 55 plus 55. And then 2 more outputs for the change outputs to Alice and Bob. So Alice contributed 90. So she wants to give 55 to Charlie. So the difference is 35. So there's 1 change output to Alice for 35 ADA. And Bob gave 10 plus 50, 60, but wants to pay 55 to Charlie. So there is a change output of 5 for Bob. Right now we the beginning of this lecture, talked about signatures. So who has to sign these transactions? And the rule is that it has to be signed by the owners of the money that gets spent. So in the first transaction, the only input belonged to Alice. And so only that first transaction only has to be signed by Alice. There's only one input, it belongs to Alice, she has to sign it because her money gets spent. Now the second hypothetical transaction has 3 inputs, 2 of which belong to Bob, 1 to Alice. So there are inputs that belong to Alice and inputs that belong to Bob. So that means that this transaction, the second one, has to be signed by both, by Alice and by Bob. So transactions can be signed by more than one person. So in that case, you would just attach not just one digital signature, but more than one digital signatures. But only the parties that own at least one of the inputs need to sign. So that's the UTXO model, unspent transaction output model. And that's more or less how Bitcoin works. And Bitcoin is also a bit more complicated, actually. Bitcoin has like rudimentary smart contract capabilities, so-called Bitcoin script, but that is rarely used, I think, and not very important. So in principle, you can think of a Bitcoin transaction something like this on this slide. Oh, it's video snapshot. Are there any questions to this?
Not in the chat yet.
Okay. Right, and now the way Cardano implements smart contracts is by extending this model. So it gets extended. So there are some things are added to it, and those things then allow smart contracts. And it's like totally different to how Ethereum does smart contracts. And I think in the beginning, maybe less intuitive, but it can actually be proven mathematically that it's just as powerful as Ethereum smart contracts. So in principle, you can do everything that you can do with Ethereum smart contracts. You can also achieve with Cardano smart contracts, in theory. But because the models are different, we have this account-based model for Ethereum and the UTXO model for Cardano. That means that the two systems have different strengths and weaknesses. So there are some things that are much easier on Ethereum and others that are much easier on Cardano. But everything, I mean, it's a bit like Turing-complete programming languages. So as long as the programming language is Turing-complete, you can do everything that you can do in one, also in the other. But that doesn't, of course, mean that all programming languages are equal. Some things are easier in some languages and other things are easier in other languages. And that's similar on blockchains. Although, of course, I personally believe that, I mean, some programming languages are better than others, like Haskell is clearly the best. And I also think that the Cardano model is better than the Ethereum model. But I mean, they both have their strengths and weaknesses. Okay, let's see. All right. Sorry, let me go back to this. Okay, so the idea is to, I mean, at the moment, these unspent transaction outputs only have 2 pieces of information. The amount, so in this example, 100 ADA, in this example, 50 ADA, and the owner, so the person that needs to sign the transaction if this is spent. So if a transaction tries to spend this UTXO because it belongs to Alice, the transaction has to be signed by Alice. So there are these 2 pieces of information attached to this output. So the idea now is to extend that I mean, there are, I think it's three things that are added when going from the UTXO model to the eUTXO model that enables smart contracts. So first thing is to extend this. So instead of just having two pieces of information, the owner and the amount, we add a third piece of information, which we call datum, and which, as the name suggests, is some more or less arbitrary data. You can think of it like JSON. So you can think that a piece of JSON is attached as well. So not just the owner and the amount, but also some data which you can think of as JSON. And it can be more or less arbitrary. The second thing is that such an input here, so what is blue in these diagrams, also gets an optional piece of data attached, which we call redeemer. And both the datum and the redeemer are optional. So we see here is no datum and there is also no redeemer. And the third ingredient is context. So, and then the idea is, I mean, the main idea of the extended UTXO model is to change the condition under which an unspent transaction output, a UTXO, can be spent by a transaction. So just to recap, at Bitcoin or Cardano before the Alonzo era, before smart contracts, the condition is I can spend a UTXO if the owner of the UTXO signs the spending transaction. That's the rule. And now for the extended UTXO model, the extension is that we change this rule. So we say it stays the same if the owner is a person like Alice or Bob. And of course, technically, we're not talking about persons. Technically, these Alice or Bob will be given by public keys, or to be more precise, by the hash of a public key. So the way this is technically implemented is, I mean, doesn't really spell the word Alice. Alice, when she wants to transact on the Cardano blockchain, would create a public-private key pair, and then she would hash the public key, and then instead of the word Alice here, what is actually on the blockchain would be the hash of her public key. And then when she wants to spend that, she creates a transaction and she signs it. Signing in the sense of what we talked about earlier. So using her private key that belongs to a public key, she would sign the transaction. And then other people, for example, the block producers who include transactions in their blocks, can verify the signature. So they can verify that the owner of the private key belonging to this hash of the public key signed the transaction. So to be sure that not somebody else tries to steal Alice's money, but that she herself, the owner of the private key, signed that. Okay. And right. And now for smart contracts, so the idea is now we also have this datum and we have these redeemers. And now the idea is that there are new types of addresses. So it's not no longer just public key hashes, so-called public key hashes, so the hashes of public keys, but it can also be so-called scripts. And by scripts, you can think of basically a computer program. So in that case, if this coin doesn't belong to a person, but to a script, then if some transaction tries to spend this, instead of demanding the signature of the person to be included in the transaction, instead, this program is executed. The program that replaces this human address here. And that program gets a couple of inputs. So one input is this datum, so this optional attached data, JSON data. Second input is the redeemer, so the datum attached here to the input. And the third input is context. And context basically means the situation. And there are various like the design space is big for this. So what could be the context? Oh yeah, and I should complete the sentence. So the script gets those inputs, the datum, the redeemer, the context, and then can say yes or no, basically. And if the script says yes, then it's okay to include this UTXO as an input to the transaction. If the script says no, then it's not allowed. And one thing to note before I talk about context is that this is like strictly more powerful than what we had before. So we can, in principle, do this signature thing for people also with smart contracts. So the script, for example, I mean, you then in that case you would imagine that the redeemer is the signature, and then the script would, because it gets this the redeemer as input, so it could check that actually it could verify the signature. So in that sense, smart contracts are a generalization of what we had before. However, it can do much more, such a script, than just verifying signatures. So it's much more powerful and flexible. And for practical reasons, it's also not done like that. So if there is a person, this is not modeled as a smart contract that checks the signatures, but so it's like two different cases. So for each input of a transaction, it's checked whether the order is a person or a script. And if it's a person, then we look for the signature in the transaction. And if it's a script, we execute the script. But in principle, you could get rid of this first case and do everything with scripts. Okay, and now what's this context I was talking about? So there are various ways. So Bitcoin, for example, also I mentioned has like rudimentary smart contracts. And Bitcoin in principle uses the same thing, the same idea. But the context for in the case of Bitcoin is just the output and the input. So that would mean the script, the program as input only gets the amount, maybe this optional datum and the redeemer, but nothing else. And it turns out that that is very limited. So Bitcoin can do some interesting things with its rudimentary smart contracts, but it's far less flexible and powerful than what Ethereum, for example, can do. So another option would be that the context is everything. So basically the script has access to the whole blockchain, the whole state, everything. And that is more or less what Ethereum does. So an Ethereum smart contract in principle can query the whole state of the blockchain at a given time. So it has a very global view of everything, which is very powerful, but also leads to all sorts of bugs and attack vectors on Ethereum, like this famous DAO hack that almost $100 million were lost in an attack. I think one could say that that was caused by this global context because unforeseeable things basically could have an influence that the authors of the script didn't anticipate. So Cardano chooses a middle way. So for Cardano, the context is the transaction being validated. So when a script is executed, as input, it gets this optional datum and the redeemer, and it sees the transaction that tries to spend this input. The transaction with its outputs, and if there were other inputs, it would also see the other inputs. So it's somewhere in the middle between Bitcoin and Ethereum. So Bitcoin only has this tiny myopic view on this, only the output and the input. Ethereum has this global view of everything, and Cardano has the view on the transaction that's just being validated, where somebody just tries to decide whether the transaction is valid or not. And it turns out that that is good enough. So you can do all these powerful things with this context. So Bitcoin is too limited. Just having a view on this doesn't allow you to do the things you would like to do. But it turns out having the transaction is being spent in the context is enough to do all sorts of cool things. And it has a lot of advantages over the Ethereum model. So that's actually one of my favorite things about Cardano smart contracts, because all of this, all the script sees during validation is known when you construct the transaction. So somebody builds this transaction. So it decides what will be the inputs, what will be the outputs. I mean, how is the money split? Where does it go? And so that means when you construct the transaction, you already know the full context. You don't care what else is going on the blockchain because you know the transaction you are constructing at the moment. And that means you have all the information that the script will get when it is executed to check whether it's okay to spend this script input. And that means you can validate or you can run the script already before you ever submit your transaction to the blockchain. And that means whether the script says yes or no, whether it's okay to spend the input or not, is completely deterministic and doesn't depend on other things that are going on the blockchain concurrently. And that means you know before you ever submit a transaction whether, I mean, what the effect will be. There are still, I mean, it can still fail even if the script says it's okay, because in the meantime, for example, some other transaction could have spent this output. So once your transaction is submitted and gets to the blockchain, it's been validated, this output might no longer be unspent. Some other transaction might have spent it. But that's okay. In that case, your transaction just fails, but you don't have to pay anything. But if all the inputs are still present and some other conditions that depend on time and so on that we get to later, then you know all the scripts will succeed and you know exactly what the outputs will be. So what the effect of this transaction will be. And that is completely independent on other things that happen on the blockchain concurrently. And that is emphatically different to what Ethereum does, for example. With Ethereum, that's simply not true. So you can't, before you submit your transaction, know what the effect will be. You actually have to transmit it. And that means there's always a risk that, for example, it will fail and you will have to pay gas fees, but it will still fail. And that's not true on Cardano. So Cardano in that sense is much more predictable and deterministic, which I think is a very nice advantage. So in certain situations, it means it's far less risky to submit a transaction on Cardano. In principle, I mean, it can, as I said, it can fail, but then you don't lose any money. But if it doesn't fail, the effects are completely deterministic. Let's see. That's there was on the slides. Oh yeah, here's right. Okay, but I think we are done for an hour now, so maybe we should have 10-minute break until 25 before we continue. And then I'll talk a bit more about the datum. I mentioned that it's there, but we haven't talked about it yet. So let's have a 10-minute break until 25.
Okay.
Okay, thank you. Okay, should we continue?
Yeah, let's go.
Okay, I mean, I don't want to start with Icon today, so I thought maybe we should use the time to do some practical demonstrations about basic operations on Cardano. So I think before I go into the technicalities of Datum, how that can be represented, maybe we should just do some basic demonstrations without smart contracts, not involving smart contracts. So let me share again. Oops, sorry. Do you have a testnet wallet, Robertino or Antonio?
Yes, I do.
Okay, then maybe we start by just using a wallet to send. I send you 108 or something.
Okay.
And look at explorers, and then I maybe can do the same thing in with the Cardano CLI. I think that might be useful.
Okay. Let's see.
Okay, so maybe just to make it a bit more practical, what I showed on the slides. Right. So in order to actually do that, I mean, people that just want to send money from A to B, they normally don't, I mean, they use so-called wallets. And there are various wallets, but the most popular and easy to use ones are browser-based wallets. So they are normally a plug-in into a browser like Chrome. And two of the most popular ones are Nami and Eternal. There's also an IOG one that's being developed called Lace. And there's an older one. What's the name now? Sorry. Mind is blank right now. The Emergo one, what's that called again? Sorry.
Don't recall.
Let me.
I think you have it in the other browser. I think.
Yeah, I do. I just
I don't recall the
I
name.
can look it up on my phone.
Yeah, but nowadays there's like 15 wallets, but these ones
Right.
are used and Lace.
Yes. I was talking about
Yoroi, yes.
Sorry?
Yoroi.
Yoroi, yes. Right. Anyway, so I can use Nami now. That's like the simplest one. And so that's now, I mean, I should say that, I mean, the Cardano blockchain, but of course, I mean, it's important to be able to try things. I mean, in general, but in particular, if you want to write smart contracts, because probably you don't get it right the first time and you want to try it out. And obviously, you don't want to risk real money doing that. And that's why basically all blockchains, as far as I know, certainly Cardano has so-called test nets as well. So there are like different blockchains that all follow the Cardano protocol, but only one of them is considered to be the Cardano blockchain. That's the so-called mainnet. But then there are others that use the same technology, the same Cardano nodes, but those are considered test nets. So the money on those is not considered not to be real. I mean, the technology is exactly the same, but they are just, I mean, they are meant to be used for testing things out. And so there are several actually. On Cardano, there's like the so-called pre-prod testnet and the, what's the other one?
It's preview, pre-prod.
Right. Preview, pre-prod, and now there's also this new one for testing the Voltaire stuff. Anyway, so there's several ones. I normally use the pre-prod one because that is closest to the mainnet. So on Cardano, there are like, I mean, on other blockchains as well, but because I'm most familiar with Cardano, I mean, there are also parameters. So various things can be parameterized in the configuration. So you could use a Cardano node, the exact same software, and start like different blockchains with different features. And for example, one of those parameters is the so-called epoch length or slot length, epoch length. Cardano has this system of reward sharing, so people that create blocks get rewarded, and on Cardano that happens every 5 days, and these 5 days periods are called epochs. And this is configurable, so you could have blockchains with shorter epochs, which might be useful, I mean, for testnets, because sometimes you want to try something related to the reward system, and if you always have to wait 5 days to see your rewards or to get them, I mean, if for testing, that may be too long. So I think preview has shorter epoch length, I think. But pre-prod, the testnet pre-prod, I think has identical parameters to mainnet. So if you, I mean, that's the testnet that's most faithful to the mainnet. It behaves basically exactly like mainnet. It's still, of course, not exactly the same because, I mean, the money is not really worth anything. So people are less careless, like less careful, more careless. And that means like the distribution of funds in wallets is not the same as on mainnet. So it's not 100% authentic. But as far as the technology is concerned and as far as the parameters concerned, it behaves exactly as the mainnet does. So for demonstrations here in the class, we can use this testnet. And the wallets that I mentioned earlier, like Nami and Nami, Yoroi, Eternal, Lace, they all, I mean, you can use them on mainnet with real money, but they all also come with ways to run them on one of the test nets. And so I want to use pre-prod. And so I have a Nami wallet here. So it's a Chrome plugin. So if you just, I suppose if you Google, sorry, plugin, then you probably will find it. Yeah. Right. So you can easily Google it and then you can, I mean, I already have it installed as a plugin. So I can only remove it, but if you want to, you could install it. Anyway,
always check that it's the original one, just in case, because
yes,
every now and then there pops up like.
Yes, there are scams. I now close my browser window. I think so. Anyway, why is this now happening to me?
It happens every day, but
Yes.
Maybe you can avoid it.
A second. But I think that was somehow wrong. I'm sorry, I was confused. I should have done this. Yeah, I know. Anyway, so I mean, because sometimes it's a bit difficult to not get confused with different wallets and different blockchains. So I use like a different Chrome identity for my testnet Nami wallet. Anyway, so I have this plugin and on the testnet. So here somewhere it says, oh yeah, here you can see pre-prod. So this is now on the pre-prod testnet. And I have all sorts of stuff, but in particular I have TestAda. And one of the features of a testnet is also that there are so-called faucets. So I mean, the question, of course, is if you want to try something on the testnet, where do you get money from for the testnet? I mean, on the real blockchain, I mean, because it's money, it doesn't grow on trees. I mean, somebody has to give it to you for whatever reason, because you earned it or whatever. But for the testnet, it's easier to get money. There are these faucets, and I always forget the address, but I always just Google testnet faucet Cardano. And then you get to this site, and here you can basically just use this website to get money. I mean, I can demonstrate that. So let's see. At the moment, I have 82,000 ADA here, test ADA in this wallet. So I can pick a testnet. So for example, I mean, so there are these two options, preview and pre-prod. As I said, I want to use pre-prod. I want to receive test ADA, and now it needs an address. So I mentioned addresses before. So that's the hash of a public key. And these wallets normally make it easy for you to get your own address. So in this case, in Nami, I can click on receive. And then this is the address. And I can copy it to the clipboard. There's also this QR code. So, I mean, some wallets, if you want to send money to somebody, sometimes it's easier to use a QR code. And then if you have, some of these wallets also work on the phone. Yoroi, for example, does. So if I now wanted to use Yoroi to send money to this wallet, I could use my phone and scan this QR code and from the Yoroi app, and then I would have this address. Because, you mustn't make a mistake. So this is a very long cryptic number, or text, this address, and you don't want to mess that up because then your money is gone. We all think blockchain is great and wonderful and blah, blah, and that's all true, but it does have certain drawbacks. If I use my real bank to send money somewhere and I make a mistake with an account number, then at least I have a chance to get it back. I can go to my bank and say I made a mistake, and then probably it's a lot of paperwork and I have to sign stuff and wait for a couple of weeks, but there's a good chance that I will get my money back. On a blockchain, if it's gone, it's gone. If the person you sent it to is nice, maybe you can convince him to send it back. But because there are astronomically many possible addresses and only very few of those correspond to actual people, chances are very astronomically high if you make a mistake that you will send it somewhere that doesn't belong to anybody. And then it's just gone, and no power in this world can get it back to you. So it's extremely important to not make any typos, and therefore you should probably never, like by hand, try to type in one of these addresses. Always like copy paste or use QR codes, or in this case, copy it to the clipboard. Anyway, in this case, of course, it's not important. It's only the test net and it's not my money anyway, but it's good to learn these practices when it's not about real money. So if I had an API key, then I could get more test ADA or more often, but I don't have one. But it's fine. So now this is restricted to doing it once a day, I think, every 24 hours. So now the money should be on its way. And on Cardano, each day is a block on average every 20 seconds. But that's there's randomness involved. So it can be faster, it can also take a minute or longer. But on average, every 20 seconds, there's a block. So if this faucet sent money to me, right, and now we see instead of 82,000 ADA, I have 92,000 ADA. So the faucet sent me 10,000 test ADA. So that's how you can, if you want to play around, how you can, without risking your own money, for free, get test ADA and then play with it. Okay, and now the simplest case is that I want to send money to somebody else, and like Robertino. So let's say I want to send 100 ADA to Robertino.
I gave you my address in the chat.
Okay, I was hoping you did. So Robertino copy pasted his address in the chat. So I copied that. Go back to my other browser, open my Nami. So now I do send. I paste his address here, and now I can give the amount. Let's say 100 ADA, and click send. And normally, as we know, now this digital signature has to be created using my private key. But the way wallets normally handle that is you don't, you never see your private key explicitly, because that's this long, complicated thing. We should also talk about seed phrases later, maybe. But once you have set up your wallet, then it's normally a normal password. So when you create your wallet, you pick a password, and then you can use this password. And then internally, this browser plugin will, once you have entered the correct password, it will use your actual private key to sign the transaction. So I must remember the password. Confirm. And that looks good. And now we again have to wait like something between 10 seconds and a minute or so until this takes effect. So let's recall it's 92,091. So it should be less than 92,000 ADA afterwards, once the transaction has gone through.
You can see the history if you change the tab
Yes.
to the last one. Yeah.
Yes, I can. I know. Okay, so here this is the history of all my transactions, or yeah. So we see at the moment the most recent one is that I received 10,000 ADA TA as a test ADA. So that was from the faucet. We also see all these zeros here. So that's another thing. Money on blockchains, and in particular on Cardano, is always discrete. So there's like the smallest positive amount. That would be if there's all zeros and the last digit a 1. And that is called on Cardano, it's called a loveless. But the unit of currency that people normally use is called ADA on Cardano, and 1 ADA is 1 million lovelesses. That's why these 6 digits here, the 6 zeros are so small. So it's 10,000 ADA, but it's 10,000 times a million, whatever that is, 10 to the 11th. So 100 billion, 100 billion loveless. And as far as the blockchain is concerned, I mean, the blockchain doesn't know anything about this distinction. So the blockchain deals in loveless, doesn't know about ADA. It's all loveless. But I mean, humans find it easier to not deal with so many zeros. So these wallets have these so-called decimals. So these 6 decimals in the case of ADA. So now we see my transaction went through. So there's a new entry in the history now, where I now spent 100 ADA. And I also see my balance is now below 92,000. And I can also expand this. And I see a so-called transaction ID here. That's again our old friend, the hash. So transactions contain like lots of stuff, inputs, the outputs, the signatures, blah, blah, blah. Although not the signatures. I mean, they do contain the signatures, but that's not hashed. So everything except the signatures, basically inputs and outputs in particular, is like some data structure, and that is hashed, and that is the so-called transaction ID. And we see this is also a link. So that leads me to a so-called explorer, in this case Cardano Scan. There are others as well. I personally like Cardano Scan. And so that's a third-party thing. For some reason, the link didn't work. I know. So that's a third-party tool that people created. I think IOG also has our own, but I always use this Cardano Scan. And we see, I mean, that exists also for the various blockchains, Cardano blockchain, so for the mainnet and also the testnet. So here we see we are now on the pre-prod testnet. I could switch that here to go to the mainnet or the preview testnet. And now we can look at this transaction from the point of view of the explorer. So you could do the same now if you wanted to. I mean, I can copy paste this transaction hash into the chat. And now all of you in principle could go to the site, open this explorer, and you would see the same thing. So even though it's a test net, it is a proper, I mean, public blockchain. So it's all public. I mean, this is like the public internet now. So here's some sort of like useful information about the transaction. I mean, first the hash, then the timestamp when it was included on the blockchain, the block number. So we see there have been more than 2 million blocks on the Cardano blockchain now. We haven't talked about fees yet. So in the diagram that I showed you from this Plutus Pioneer program video, the numbers always added up. So Alice wanted to send 100 ADA, so the input was 100 and the output was 10 for Bob and 90 change for her. In reality, it's not exactly like that because you also have to pay transaction fees. So the outputs are normally a bit higher than the inputs. And this is then used to pay for basically the operations of the Cardano blockchain. So to pay the block producers, for example. This assurance is, we talked in the very first lecture about this common prefix property. We said the deeper some block is in the blockchain, the more unlikely it becomes that it will go away again. So, for example, at Bitcoin, people tend to wait for an hour until they can be sure that nothing will change anymore. So, two confirmations means that this transaction is in a block where two more blocks have been created afterwards. So, on top of that, so it's now a third position in the blockchain. So over time, this will increase, but I think it doesn't auto refresh. So if I refresh the page, you'll see now we already have 9 confirmations. So since I was talking, so now there have been 9 additional blocks on top of this block that contains that transaction. So now it's already very unlikely that there will be a rollback and this will change again. So Robertino can be reasonably sure that he will not lose these 100 ADA anymore. Okay, I talked about epochs. So there are slots and epochs. A slot on Cardano is once a second. But as I also said, block is only on average every 20 seconds. So every second there's a 5% chance that the block will be produced. On average, that means that every 20th block slot, there will actually be a block. And 5 days are an epoch. So we are now in the 131st epoch. And it's this slot, this is the absolute slot number. So there have been 55 million slots. So 55 million seconds since Cardano started. And this slot number here, I think, is the slot number in the epoch. So in epoch 131, it's the 135,000th slot. Right, we can ignore this for now, I think. Right, so this is, I mean, that shows from my wallet 100% plus transaction fees, and this will be Robertino's wallet. So he received 100. But for us, maybe now more useful is this UTXO view, because now we see that even though, I mean, it was a simple transaction where I sent just 100 ADA to Robertino, actually my wallet decided to create a transaction with 2 inputs and no, 1 input, sorry. Yeah, only 1 input. What's that? Yeah, sorry. Okay, 1 input, but 3 outputs actually. And the wallet basically has like various reasons to somehow decide what to do. So we see, I mean, the coin I used was 353 ADA, and there was actually not just ADA. Cardano also has something called native tokens that we will talk about later. So everybody can create their own currency different from ADA. So in this output that I spent to pay Robertino was not only ADA contained, but also some of these other tokens. But we can ignore them for now. So definitely I paid too much, 353. And now we see there are 3 outputs. So the first one is the one to Robertino, exactly 100 ADA. And then my wallet decided to do 2 change outputs for whatever reason. So one contains these tokens, these additional tokens, and just a small amount of ADA, which always has to be present in every output. So that's an additional rule in Cardano that outputs can't be arbitrarily small. They always have to contain something called the min deposit. They always have to contain some ADA, so roughly 1.2 ADA or something. The exact amount depends on what else is there. The more stuff you have in the output, the more ADA you must include. And that is to keep costs in basically in synchrony with actual physical costs. Because as I said before, the state of the Cardano blockchain is given by this set of UTXOs, unspent transaction outputs. So every Cardano node, every person that participates in the blockchain and runs a Cardano node needs to be aware of this UTXO set. So in principle, that set has to be in memory, in computer memory of the Cardano node, or at least it has to be saved on hard drive or something. So that means the bigger that is, the more resources you need to run a Cardano node, because you have to save that information somewhere. So that means it's expensive. I mean, the more UTXOs there are, the more outputs there are, the more expensive it becomes for people to do the computations, because they need more memory. And that's this min deposit is supposed to compensate for that, to basically create a counterbalance to prevent people from just creating hundreds and thousands and millions of UTXOs. If you could do that for free, then some malicious actor could create a lot of UTXOs just to increase memory demands on Cardano nodes and basically force them out of memory, and then the blockchain would grind to a halt. So in order to prevent such a DDoS attack, basically, there's this minimal deposit. So it would be prohibitively expensive for somebody to create so many UTXOs. You would need millions of ADA to actually cause the damage. But nevertheless, so we should, if we now add the inputs and the outputs, it should almost add up, and the difference should be this fee. So these 0.17 ADA. So the fee is also not a constant. That depends on the size of the transaction. Where size doesn't mean how much money, it means how much data is contained in the transaction. So if you have lots of inputs, lots of outputs with complicated datums and lots of native tokens and so on, then the transaction needs more storage space, and then it becomes more expensive. But there's always, even the smallest transaction, the smallest possible transaction always has something like 0.16 ADA or so. And then if it gets more complicated, it becomes more expensive. Again, to have actual physical costs reflect the transaction cost, or the transaction cost should reflect actual physical costs. Because if the transaction is bigger, then you need more computational resources to process it. Right. And as you also can see here, most of these things are, again, hyperlinks. So I could now click on, for example, on this address. This is my address. And now I, for example, see the previous transactions. So again, this is now similar to this view. So that should be exactly what we saw in the wallet as well. So this first transaction is the one where I sent 100 ADA to Robertino. And then we see the one from the faucet where I got 10,000 ADA, and then some previous stuff I did. So this is basically exactly that. One other thing I could mention is, sorry, so this is my address. But if we look here, or here rather, sorry, I'm still in the UTXO. Then this looks different. So it doesn't say address something, it's stake, test, blah, blah, blah. And that's another thing that basically wallets add on top of the blockchain. I mean, Cardano is proof of stake. So that means that the more ADA you have, the higher your chances to be able to produce a block. However, not everybody wants to produce blocks. I mean, I right now don't want to produce blocks. I'm not running a Cardano node here. I'm just using this wallet in my browser. So I don't want to run the node. That's quite expensive to run a node. I mean, it's not as expensive as a Bitcoin node, but I mean, you need by now, I don't know, 150 gigabyte of hard drive space, and you need something like at least 20 gigabyte of RAM. And so it takes quite a lot of computational power to run a node. So most people don't bother. And they can delegate their ADA to somebody that does bother. And then they, by doing that, they basically give their voting rights or their right to create blocks to somebody else. And that somebody else is so-called stake pools in Cardano. So people that run nodes create so-called stake pools, and then other participants can delegate their ADA to those stake pools. Then the stake pools, the more ADA they get delegated, the higher their chances to produce blocks. But the people that delegate these ADA also get then part of the rewards that the stake pools get for producing blocks. And that's all on the blockchain level. So other blockchains like Bitcoin also have similar arrangements where people form these so-called mining pools. But that's all like off-chain agreements where people just come together, have a beer and say, hey, let's split rewards and pool resources. On Cardano, it's built into the blockchain protocol itself. So this delegation and reward sharing thing. Anyway, and that's one thing. And when you, in order to delegate it, I'm not sure we should get into the nitty-gritty details now, but there's like a different key pair involved, the so-called staking key that you use to do these delegations. And what you see here is basically the staking key, not the address itself, the pub key hash of the payment, so-called payment key. And wallets normally are identified by their staking keys, not by their payment keys. In the case of Nami, that's a bit silly because Nami only has one address. So this address we saw here, this is the only address I have there at Nami. But there are other wallets like Eternal or Yoroi that use so-called HD wallets. Also a topic I don't really want to get into, but it means that in one wallet you use, or you can have like lots of different addresses that all belong to you. And in principle, for each transaction you do, you can create a new address. But all these addresses basically have the same stake, normally the same stake key associated with them. So you can sort of identify a wallet, even though the addresses are different, by the stake key. And that's why the explorers normally choose to display the stake key and not the address itself. But that's all stuff that's not directly, I mean, that's not the blockchain, that's basically wallets. So the blockchain itself doesn't know anything about these HD wallet things. For the blockchain, it's just about transactions, about addresses, pub key, payment addresses. Anyway, so that's explorers for you. I'm not sure, should I say in that context anything else for this example of sending 100 ADA, Robertino, you think?
I think it's fine. Yeah.
Okay,
we cover everything. I mean, Explorer is going to be one of the main tools you're going to use to explore, because with the terminal it's a bit annoying.
Yes, it is. And I also always find it quite cool that, I mean, we can do these demos, and I mean, I did this now as a demo, but in principle, every one of you could now check this transaction ID and you would all see the same information. So it's really a global impact we have. I mean, it's only toy money, of course, but the blockchain, the testnet is very real. It's an actual blockchain running the actual software. And it's actually, I mean, it's like distributed, decentralized, and you can see like transparently what we did in your own browsers in principle. Right. So this is wallet, but this is, as we saw already, quite high level. Oh yeah, maybe one thing I should say. I could create a new account. So if you first install that, you would, I mean, you don't have anything yet, so you have to start by creating a new account, and then you can give it a name, whatever, and you can pick a password. Okay, this is like, okay, that's easy. But normally, I mean, Nami is really, I wouldn't recommend Nami for serious money, actually. There I would recommend something like Eternal. And the way it normally works is different. So I mean, Eternal is another wallet like Nami. So I could send 100. Let me just do this. Why not? I think we have the time. So I can send
the one on top.
Yeah. Sorry.
Also, we have a question there. Maybe you can answer it after what you're going to do.
This one, what ways are there to earn ADA if I run a Cardano node?
Yeah.
Well, if you run a successful Cardano node, then you automatically earn ADA. So for every block you create, you basically get some ADA. However, in order to, I mean, as I said, because it's proof of stake, on Bitcoin, proof of work. I mean, if you want to earn Bitcoin by creating Bitcoin blocks, you need to run a Bitcoin node, and then you need to solve these so-called hashing puzzles. So every, I don't know, 10 minutes or so, when there's a new Bitcoin block, basically there's this cryptographic puzzle, and then you have to solve it. And there's, of course, specialized software to do that. I mean, you don't have to solve that by hand. And if you can solve it before anybody else in the world, then you can create the next Bitcoin block, and then you get a shitload of money. Like, I don't know how much it is these days, $12,000 or something. No, Bitcoin. No, I forgot. But I mean, at some point it was like tens of thousands of dollars you get for that. But the problem, of course, is that the whole world is competing against you, and people throw serious money at that. So there's specialized hardware, and people move to places where electricity is cheap, like China, or where cooling is cheap, like the Arctic, Alaska, and places like that, and have huge so-called mining racks, like server farms, and all those things do is day and night try to solve these hashing puzzles. And if they succeed and you are the first one in the world to solve this particular one, then you get the money for this Bitcoin block. And that's a lot of money. But I mean, because it's so much money, people are trying really hard to be faster than you. So you need a lot of hardware to have a chance. Although in principle, you could install a Bitcoin node on your laptop and run it, but then it's astronomically unlikely that you will ever be the fastest. Okay, and Cardano is proof of stake that works differently, so speed doesn't matter. Cardano, your chances of creating a block are proportional to how much ADA you have. So the easiest way to earn ADA with running a Cardano node is to have a lot of ADA to begin with. So if you have like 1 million ADA, then you're good to go. You can just start your node and you will make money every week. Obviously, that's like a chicken egg problem. I mean, where do you get ADA in the first place? I mean, of course, if you have like dollar, then you can buy ADA, set up your node, and then you earn every week. But the other way I mentioned before is delegation. So even if you don't have much money yourself, much ADA, if you run a node, you can try to convince people to delegate their ADA to you. And that isn't, by the way, as insecure as it sounds. So people that if I delegate my ADA to a stake pool, I still have control of my ADA. It doesn't mean that I give somebody my money. I just give my voting rights to somebody, but I can still spend it. So it's still in my wallet. I just forfeit my voting rights to a stake pool. So the realistic way to make money running a Cardano node is to convince other people to delegate their ADA to you. And the way people normally, I mean, there are various strategies. So it's like social engineering. So for example, if you are the first person doing that in Kenya, then you could advertise on social media, hey, join the first Cardano stake pool in Kenya. Probably there will be one already, I don't know. Anyway, so you need some angle. I mean, some people do it geographically, like the first African stake pool, the first whatever Icelandic stake pool. But there are other people. I mean, there's also some configuration, so you can give your delegators more or less share of your profit. So you can try to give them more share than the competition to attract people. Or you can have like a good cause. So I, for example, delegate to a stake pool that like does animal welfare. So there's this stake pool. I mean, the owner of the stake pool pledges to use the money she makes with that to like donate to dog shelters and stuff. So there are also, I mean, you can have a cause, or you can whatever use green energy to run your stake pool, or donate to charity, or donate for Trump's re-election, or anything. So something like that. And then normally, I mean, what people do is you sort of, I mean, you need to advertise in social media and convince people to delegate their ADA to your pool. And once you attract, I forget, I think it's what was it, 500,000? There's a certain, or 5 million, 500,000, I think.
It's more, I think now. It's maybe 5 million. I can check it out.
Right. There's a certain, I mean, pools, I mean, that's a different topic actually. But I mean, one of the problems with Bitcoin is they also have these mining pools, these informal ones, not enforced by the blockchain protocol. And on Bitcoin, there's incentive for pools to work together. Because if you have two Bitcoin mining pools, then they can make more money if they collaborate. So if they throw their resources together, then basically they double their income, but they don't double their costs because by working together, there is some synergy. So there's an incentive on Bitcoin for pools to grow larger and larger. And that is a problem because consensus relies on the fact that there are, I mean, many independent actors. And on Bitcoin, there's actually a problem that the, I don't know, 3 or 4 largest pools have more than 50% of the hashing power in the world. So in principle, in Bitcoin, very few pools have all the power. Now, Cardano, we wanted to prevent that. So built into the protocol about delegation and so on, is a mechanism that prevents our stake pools from becoming too big. So in principle, Cardano stake pool can grow as large as it wants, but rewards are kept at a certain limit. I'm not sure, maybe it's 5 million ADA or so. So as soon as a stake pool has attracted more than, let's say, 5 million ADA, then the rewards don't grow anymore. So that means that people then can make more money by delegating to a different, smaller stake pool. And that has the effect, hopefully, that on Cardano, we will never just have 3 or 4 big pools, but like 2,000 small ones that all have roughly the size of 5 million ADA or whatever it is. Yes, so that's basically the idea. You run a Cardano node. I mean, that is cheap. That can be done on a Raspberry Pi, so the hardware requirements are not very high. And then you must be good at convincing people to delegate ADA to you. I mean, those people don't lose any money doing that. There's no risk for them. The only risk is that they might get fewer rewards from you than from others. But if you manage to attract like 5 million ADA in total, then your stake pool will do as much as possible. And then you get that money every 5 days. And you have to share that with the people that delegated to you and can keep part to yourself. So that's how that works. And I have no idea how successful people are doing that, but some, I think at least, can basically live from that. So if you have a successful stake pool that's saturated, has this maximum 5 million or so in delegation, then I think it's quite a lot. I mean, you don't get rich necessarily, but it's not bad. But I don't know how much money it is exactly, but a couple of $1,000s a week, or potentially, if you have a very successful stake pool. Oh. Right. Oh yeah. Okay, great. Okay, yes, I wanted to demonstrate Eternal. So this is this Eternal wallet now. I have an existing one. So this looks different. I mean, the layout is different, but same thing. So if I want to send 100 ADA to Robertino again, is again this send. I can type his address or paste his address and then say how many ADA. So let's say 100 again. And now here's also a password. I hope I remember that correctly. Yeah, okay, fine. But what I actually wanted to show you is here, if I want to create a new wallet here, so I have various options. For example, I can restore. There are also these so-called hardware wallets, and I can create a brand new one. If I do that, then I give it a name, for example, Kenya. pick a password. And save. And now, I mean, eTortle also has these so-called accounts, so you can have like sub-accounts of your wallet. Let's ignore this for now. Yeah, okay. Now I'm lying. I confirm that nobody can see my screen. Right. And then you get this so-called recovery phrase or seed phrase. So, I mean, as we learned before, it's all these public and private keys. So what this now is supposed to, I mean, in principle, now what the wallet software does is it creates this key pair, public key, private key. But this private key is like almost impossible to remember. I mean, it's this long string of letters and numbers. Therefore, I mean, this is already, I think, pioneered by Bitcoin, and I mean, all the other blockchains use it as well. So there's this scheme to, instead of you having to remember your private key, instead you have to remember this so-called seed phrase or recovery phrase. And that depends on the blockchain. There are different schemes. I mean, it's not always 24 words, but I think it's like a fixed number of words. So there are, I don't know, 500 potential words. And then from those 500, some are randomly picked, basically. And now, I mean, I'm too lazy to do this now, but what you're supposed to do now is write those 24 words down on a piece of paper, ideally not online. So the most secure way is to do that offline on paper, or ideally to engrave it in metal or something, titanium. So in case there's a fire. And then I think I mean, if I now say yes and continue, then I think now I'm supposed to prove that I wrote them down. So I didn't. So now I can't continue. But I don't want to write them down now. But the idea would be I would write them down, then I go to continue. Now I have to like type all of them in the 24. And then my wallet is set up. And the point of the seed phrases, I mean, I normally don't need that. As we saw before, I just need this one password. But if, for example, my laptop breaks, or if I deinstall this extension or whatever, or if I go to a different, I mean, if I travel and don't have my laptop with me. So now whenever I get access to another eTortle wallet, or it doesn't even have to be eTortle, it can also be Yoroi or Lace or so, then as long as I know these 24 words, I can, so if I now, let's imagine this is now a different computer, and I want to have access to my money, I could now, instead of creating a new one, I could do a restore wallet, and that was 24 words. And now I could enter those 24 words that I wrote down before, and then I would have restored my account. So the 24 words are what you need to access your money and nothing else. So you can also forget this password. I mean, that's annoying because then you have to like enter these 24 words again and pick a new password. But in principle, the password, those 24 words are exactly what you need to get access to your money. And so as long as you have them, all is good. It doesn't matter. I mean, your laptop can go up in smoke, and I mean, you don't need anything. You don't need a passport or a social security number or anything else. But whoever has these 24 words has access to your money from anywhere in the world. So it's a curse and a blessing, basically. So as long as you have those words, all is good. But if you forget it, then there's no way anybody in this world can help you to get your money back. I mean, when I go to these blockchain conferences, there's always one stand somewhere where somebody claims they can recover Bitcoin wallets. And I mean, you always know that's scammers because it's not, I mean, it's just not possible. Right. So it's extremely important if it's real money to keep this recovery phrase safe. And there's a whole industry like there. I mean, when I said engrave it in titanium, that was not really a joke. I think there are companies that offer that to basically engrave your recovery phrase in metal so that even if there's a fire in your house, it's still safe. So probably if you're really paranoid, you should write it down several times and then put the copies in different bank vaults or at different places. So even if there's an earthquake, you still have it. Anyway, so that's that. So that's this. But what it does is just it sort of encodes this private key. Okay. And now, so this is how people normally deal with these things. So they use a wallet and don't really have to worry about private keys and picking inputs and outputs explicitly, because they can just use I mean, the wallet software that takes care of that. So it's almost as if you do normal online banking or M-Pesa or whatever. It's almost as convenient. I mean, we know this UTXO model. You have to pick inputs, you have to create change outputs and so on, but the wallet does all of that automatically for you. However, you can, if you want, also do it like close to the metal by hand. So I wanted to also demonstrate that at least once. And that is where Cardano CLI comes in. Oh yeah, sorry, that's still my demo running. Right, so there's something called Cardano CLI. I have it installed. If you go to the Cardano node, if you Google Cardano node, then you can basically follow the instructions and download that if you want. And I think in our repo, I'm not sure, Robertino, maybe not in the version we have now, but we do have a version where that's also installed. So in the Visual Studio Code dev container, we have installed it for you. So once as long as you are in there, you should have access to that as well. Not sure about the one we were using now for Haskell, but we definitely for later lectures, we have something like that.
Yes,
okay.
also maybe comments that when you use a wallet, you don't need a node because the wallet itself uses a remote node.
Right. So I mean, as you saw, when I just needed this browser extension. I didn't need to run my own Cardano node. And the wallet, I mean, there are third-party providers like Blockfrost and Maestro. So companies that basically run Cardano nodes for you, and then these wallets normally use those companies to interact with the blockchain. So you don't have to install anything except this extension. But of course, if you want, you can run your own node, and then you can use this Cardano CLI, Cardano command line interface, to talk to the node and create transactions and submit them by hand, basically. And I think every person serious about Cardano should have seen that at least once or done that at least once. I mean, you never have to do it again, but I think it's sometimes good to know how things work at the lowest level. Right, so I so happen to have a node running, not on my local machine, but on a AWS server. I hope it's working. Yeah, I think it's working. So one way to see whether it's working is can use the Cardano CLI. And one thing I like about the Cardano CLI, I mean, it has hundreds of functionalities, but it has a very good, I think, help system. I mean, very, very primitive, but I mean, very basic. But you always, at every level, you basically see the available commands, and then you can, I mean, one of the available commands is, for example, query. And then I can do that, and then there are subcommands, and one of those is tip. Right, and that will now, if I run that, it should tell me whether, I mean, connect to my node and tell me whether my node is up to date following the tip of the blockchain. If I do it just like this, then I get an error because I haven't told the tool where to find my node. So I can either give this socket path, or I can set an environment variable. So I think I do that because I only have to do that once, and then for the other commands that need to talk to a node, I can use that. So set that. One thing I really hate about the Cardano CLI is that all the names are so frigging long. So it's always a lot of typing. There's also a way to get auto completion installed, but I always forget how that works and then I never bother. Okay, so that is the, I mean, here in this tab, I connected to my AWS server, which has this node running. And now this is the path to the socket. So we connect to a node with a Linux file socket. Okay, and now let's run this thing again. Not now. Oh yeah. I must also tell it which blockchain. So not mainnet, I want testnet. And I always forget, is it 1 or 2? I think it's 1. So the preprod and the preview have different so-called testnet magics to distinguish them. And I think preprod is 1. Yes. Right. So now I successfully connected to this node via the socket to my AWS server. And now I get some information. So right now, block is this, epoch that. I mean, that looks familiar to what we saw in the Explorer earlier. And we see sync process 100%. So my node is up to date with the progress of the blockchain. Right. And now if I want to really do everything from scratch, I mean, the very first thing I need is I need to create such a key pair, right? Private public key. And the Cardano CLI is your friend and can do this. So I could scroll up or I can type Cardano CLI -- help again. And I always forget, I think it's key in this case, or it could be address. Let's try key. It's not, it's address, which I find super counterintuitive. But anyway. So the address subcommand has a subcommand key gen, create an address key pair. So that's this public private key pair I need to basically create an identity for me. So I can do this, key gen. Now I need a couple of, I think for this step, I wouldn't even need to be connected to a node. I can do that offline basically. But anyway, right. So I think most of them I can ignore. I mean, the default are good. But I must say the verification key file, so what I called public key in the slides, in Cardano it's called verification key. What I call private key is called signing key. So I must provide those two files. And that's what I meant with freaking long names. Instead of calling it vkey or something, it's very, I must really type this out, which is very annoying. But normally, I mean, I also don't do that by hand. I create a bash script because I normally never get it right the first time. And then if you have it in a file somewhere, it's easier. Right, but I think this I can do by hand. So let's just call it Lars key. And now signing key file Lars S key. Okay, so it doesn't complain, so it probably worked. So now I can look at those files. So it now created 2 JSON files that contain my key. So it's some meta information. So it, for example, it says that this is now a verification key, payment verification key, payment, because as we alluded to earlier briefly, there are also other types of keys on Cardano, like these staking related keys. Okay, so this is payment key, and this is the actual key. So the hex of the actual key. And I can also look at the secret key. Of course, normally you would never share your secret key with anybody, but now, I mean, there's no money there anyway, and it's on the testnet. So I can share it with you for this lecture. So this is basically what wallets hide behind these 24-word recovery phrases. So this is the actual key. Okay, so I have created those two now. Now I need an address, and an address is, as we said, is basically the hash of of the public key. But I don't have to do that by hand. The Cardano CLI is my friend again. Because there's in the address command, there's the build subcommand, which builds an address. So instead of keygen, so I have the keys now, I can do the build subcommand. And now there are various options, and this is also works for scripts. So when we talk about smart contracts, but it also works for these like normal addresses. So I can give the payment verification key file. Payment verification key file. And that was last week key. And I don't need the signing key for this, because the address is just more or less the hash of the public key. And now I must specify for what, which blockchain, because mainnet and testnet addresses look differently. Testnet addresses have this word test in front to make it unlikely that you by accident like use a mainnet address for a testnet or the other way around. So I have again this testnet magic 1 for preprod, and I must specify the out file. So I can call that last address. Okay. Right, there is the address. So now I could, for example, use Nami to send money to this address. Before I do that, let's look at another CLI query app. So earlier we had this tip, but much more fun is address. Right, so this is this UTXO. And there, okay, I need to connect to a node for this, but I have set this environment variable. I can ignore all of this. I can specify an address. So if I, for example, let me close this eternal thing again. If I, for example, use this Nami address here, and now I also have to give the testnet magic again. If I do this, then I should get all the UTXOs that are currently at that address. So in principle, I should see all of this. Yeah, that was the new one I created. Oh, should have used that address because there is nothing at the other one. I'm still busy anyway. I don't know why it's so slow. Anyway, what I wanted to say is, in principle, I should now see all of this here. But I mean, here it's displayed nicely, sorted by token. But I, using this command, should now see all the UTXOs. Okay, and there I see that there are like lots and lots and lots at that address. So these are all the UTXOs at that address. And the way it's displayed is, so a UTXO, we haven't talked about that before, how it's actually like represented. But it is, I mean, unspent transaction output, so it's an output of a transaction. So it's identified by the hash of the transaction that produced this output, and then the index, because a transaction can have several outputs. So the first one has index 0, the second one index 1, and so on. So those two pieces here uniquely identify the UTXO, and then it gives the amount. So this one, for example, has 103,648,910 Loveless. As I said before, one ADA is a million Loveless, so this is 103 ADA. So they have a coin lying around there that's 103 ADA. and we see others that don't just have Loveless, but also other tokens. And I mentioned this datum stuff before. So here we see datum out, TX out, datum none. So those don't actually have datum. So there is no datum attached to it. I'm not sure whether in that wallet I have any example where there is datum attached. I think not, probably not. Anyway, and if I, instead of this address, use the address that I now newly created, I don't want to type it, so but I can use bash magic to not have to type it. Then there shouldn't be any money there because I just created this fresh, so there's nothing there yet. So we get this empty table. Okay, but now let me send some money. So let me copy this and go back to Nami and send 100 ADA to that address. Okay, and now I can try this again, and probably it will still be empty because we have to wait a couple of seconds again. At some point, hopefully the 100 ADA should be there, and then I can show you how to create a transaction from here. But I first need some money. Was there a question?
Yes, I got a question.
Mm-hmm.
So what kind of information is normally attached to the datum?
That really depends on the use case. I mean, we will see many examples of smart contracts, so it really depends on the smart contract. It's often some sort of state, but what that means really depends on what you want to achieve with the smart contract. So it's hard to say. It can be a counter or whatever, other addresses, or but we will see examples, and that will hopefully make it clearer. In principle, it's arbitrary data.
Okay.
It's really like JSON, but we will see how to actually use that, make use of that later. Okay, now the money is there. So, and actually, if I look in Nami again in the history, so it's here. And here we see the transaction hash. So it starts with C005. I mean, it's a bit small, but and we see that here we see the same. So as I said before, transaction outputs are identified by the transaction that produced them and the index. So we see it was this transaction that I just showed you in Nami. So that produced this output. That's the hash of the transaction. It was the first output. We could also look this transaction up in the Explorer, then we would say the same, and it was 100 million Loveless, so 100 ADA, and no datum attached. So now I have this now I have this. And now as the last thing, let's actually try to send Robertino 50 of those. And maybe now I should actually create a script. So I just open another tab and call it, I don't know what I call it, TX shell. Yeah. Sorry, let me just the tab with the node. I just must make it executable. Okay. Okay, Cardano CLI. Okay. Right, now I want to create a transaction. So that's the command is called transaction build.
There's an extra A in the transaction.
Thank you, Robertina. transaction build. And there is now a lot of parameters we can give. I normally just start basically empty. So if I just execute this, of course it doesn't work, but normally, I mean, you can do it as you like, of course, but sometimes it says what's missing. Because I didn't do anything now, probably it's
yeah,
for example,
maybe if you specify Babbage, it will know.
Right, but it's the default anyway. Okay, let's specify the testnet magic at least. See whether I get a different error message now. Not really. Oh yes. So now it says missing txin change address out file. So that means it complains that I didn't give any inputs to the transaction and I didn't say where to write the resulting transaction. So let's first do these two and the change address. So this transaction build command is actually not, I mean, I promised to show you how to build a transaction low level. There's actually an even lower level. There's this build subcommand. There's also a build raw subcommand. They really have to do everything by hand. This build command is slightly more high level because, for example, it automatically calculates your change and sends it to this change address you provide. So let's do this then. So I give the change address. Forget change address. So I want to have the change back to myself. And what was it? Okay. Oh yeah, and out file, let's say, I don't know, tx, was it out file? Yeah. Let's call it tx unsigned, because this command will produce an unsigned transaction. Not again complaining, of course, that I didn't specify an input. So if I run this query thing again, so I must specify what coins to spend in this transaction. The moment I have no choice because the only coin I have is this one. So can specify one tx in, and the format is you basically give the identifier of this coin. As I said, that's the transaction hash and the index, and the syntax is with the hash between, like this. So this is the hash, that's the hash index. So like this might already work. No, because I mean, now I don't have an output. So now I would basically just send all the money to myself. But now I want to send 50, I said, to Robertino. So that's with tx out. And here the syntax is, first I need his address. So that's this one. Like that. And now I can plus how much I want to send. So in the case I just want to send Loveless, I just write that. So I want to send 50 ADA, 50 million Loveless. This could actually, oh, and I forgot the backslash here. Might work like this already. Let's see. Can that possibly take so long? Okay, fine. Okay, that seems to have worked. So now I created a transaction, but nothing happened on the blockchain. It was just this transaction was created. So I can check whether this tx unsigned file now exists. And this is now the serialized form of the transaction. So it just says it's a transaction, and this is basically the hexadecimal representation of it. I think there's also a transaction info command or something. view. So I can give it this tx body file, tx unsigned. Right, and now we basically see, I mean, some information about the transaction we created. So it has the ERA, the fees, the input, the outputs, which is only 150 ADA, no datum, testnet. This must be the change output. So now in this view, this is just another output. So that's the 150 ADA to Robertino, and this is the change to me, and it's not exactly 50 because I also have to pay the transaction fees. Right. And now, I mean, like that, it's useless because it's not signed. So next step is I have to sign it, and there's a transaction sign command. Okay, and I can do this in the same script. So Cardano, I mean, I could write a new one, or actually I can maybe, it's not bother. Let's do it by hand. So Cardano CLI transaction sign. So tx body file is the file I just created, where I created the transaction. So that was this tx unsigned. Now the output file, let's call it tx signed. Now I mean, this is now the main point. I mean, in order to sign, I must have my private key. This is now where I really need my private key. That's the first time I need my private key to actually create a signature. So I can specify the signing key file. It was last S key. What else do I need? Again, this testnet magic 1. And, oh no, sorry, the TX file. Sorry, that was wrong. I confused this. This is if you already have a signed transaction and you want to add a second signature, like in my second example in the video where Alice and Bob together do something. So I need this out file here. Out file is tx signed. And that worked immediately. And this signing is very quick. And now we have this this one. And I think if I do this view thing again, and this time not with tx body, but with tx file, and now use the signed one, then this first step is the same as before. The input, the two outputs to Robertino and my change output. The difference is now we have so-called witnesses. And there we see this signature. So this is now the signature I added. Right, and now the last step is I can submit it. Actually submit it to the blockchain. This is with transaction submit, unsurprisingly. So I have to specify the testnet magic 1 and where to find the transaction was my tx signed, and that's all. Okay, and now it was submitted, and now I can hopefully I don't know why sometimes it takes so long. Okay, right now we see it hasn't happened yet because I still have the 100 ADA there. Okay, now it happened. So now I only have the 49 ADA change. And we see the transaction that I just submitted must have this hash. So in principle, now I can, for example, go back to the Cardano Explorer. So Cardano scan, go to preprod and paste in this transaction hash. And sometimes this is like slower, even though we saw in the CLI that it already happened. It sometimes takes a bit longer until the Explorer actually picks it up. Maybe they wait for one block confirmation or something. Not sure. There it is. And there we see, like UTXOs, for example, the input was this 100 ADA coin I sent to myself from Nami earlier, and the two outputs, the one to Robertino, the 50, and the change output to myself. And we see here that, so this should be the address that it should also be, this FITX plus address test1vq test1vq. Yeah, so that's that one. So that's the address I just created with my public private key pair, and the change goes back to myself. And this is Robertino's address. And in case you wonder why Robertino's address is so much bigger than mine, that is because addresses in Cardano also have the staking aspect. I talked before about delegation. So there's like the payment addresses that control who can spend your money, or the money sitting at the address, and then the staking address, which controls which stake pool, for example, this ADA has been delegated to. And those are optional. So wallets, if you use Nami or Eternal or Yoroi, then normally you always delegate, because why would you give up on the money? It's basically free. It doesn't cost you anything. By delegating to a stake pool, you can earn some money. So almost everybody does that. So the wallets do it more or less automatically. When you create a new wallet, then they automatically generate a stake key for you. And then in the wallet, you can delegate to a pool. I haven't shown you that, but in Eternal, for example, after I create this new wallet, I can delegate, and then there's a list of all the stake pools, and then I can delegate to one that takes care of stray cats or whatever. Right, and so that's optional part of an address. So the first part, the payment part, controls who can spend the money, and the second part controls the staking aspects of the money. But the way I did it now in the CLI, I didn't set this optional part, so I'm not participating in staking. But I could also do that in the CLI. So this Cardano address build command had much more parameters. I only used the one, I only gave it my public key, but I could also have given it a stake key in addition, and then the address would have been longer as well, and would have the staking part as well. Right. So in principle, with the Cardano CLI, you can do almost everything, but you don't really want to. Although I sometimes find it useful, and I sometimes use it for stuff, because it always works. It's actually quite useful. But normally you try to use higher level tools that you don't have to worry about the nitty-gritty details. But as I said before, I think it's useful to at least do it once. I personally can understand things better when I have first done them the hard way, before I learn the tools to make my life easier. But of course, people are different, so it might be different for you. Right, are there any questions?
Not in the chat.
So you should now have how much? 250 ADA, Robertino?
Yes, I already have some prior, but I'm a bit more rich, fake rich.
Fake rich, unfortunately, yeah. Okay, right. So we only have 10 minutes, but maybe I can go back to this video. Sorry. Just wanted to, datums, there was a question already, and we will of course talk about that more when we talk about smart contracts, but maybe I should just get that out of the way right now. This is a bit of a mess, and I think it's very annoying, but that is has historical reasons. So for historical reasons, there are 3 ways to attach a datum to an output. And as we also saw, you don't have to. So in the transactions I showed you now, I didn't bother with datum, so there was no datum attached. But when you work with smart contracts, there has to be one. So a smart contract, you can only spend money sitting at a smart contract address if it has a datum. I mean, the datum can be trivial, like corresponding to the Haskell unit value, but there has to be one. Otherwise, it just doesn't validate. So if you send money to a smart contract address without a datum, then it's lost. That's like burning it. Can never be retrieved. I think there is a Cardano improvement proposal to change that because that's annoying. But at the moment, at least, it's like that. If you send money to a script without datum, then no matter what the script says, it's gone. Nobody can ever retrieve it again. Anyway, so there are 3 ways. So historically, the first one was this one. So the person creating the transaction that wants to attach, I mean, the datum, as I said, is part of the output. So the person that creates this transaction that has that output is the one providing the datum. The redeemer comes from the consuming transaction. If somebody wants to spend that output, that person creates the redeemer. But the datum comes from the person who produced that output. Okay, and that historically the oldest method is that, so you create a transaction, you want to attach a datum to an output, but you don't actually attach the datum, you only attach the datum hash to the output. So you, I mean, whatever datum it is, you hash it, and then when you build the transaction, you just specify the datum hash. So the actual datum is not on chain. So you transmit the transaction, and all that's on the blockchain is the hash of the datum, not the datum itself. So, and actually, when you want to spend this output, the spender has to provide the datum then. And then the node will check that the datum the spender provides actually hashes to the right value given here. I mean, I'm still annoyed after 3 years that they did it like that, because that's normally not useful. Because how must people know what datum corresponds to this hash? I mean, that only works if that's somehow communicated off chain. But I mean, there are sometimes cases where it makes sense. So when you want to spend an output like that, whoever spends it needs to know the datum, and then in the spending transaction provide it. And then the node checks whether that datum that the spending transaction provides actually hashes to the correct hash that's contained in the output. Okay, then the historically second way is, again, the producer hashes the datum and attaches it to the output. But additionally, the producer also attaches the datum to the transaction itself, but not to the output. Like technically it's in the transaction body. So we have like a transaction has so-called body with like general information, and then the inputs and outputs. So this is in the body of the transaction. But that means that the datum is actually on the blockchain. And that means, I mean, still the consumer has to provide the datum when he wants to spend this, but at least now he has a chance to find out what the datum actually is, because he can look on the blockchain. In the first case, it's nowhere. So the only way the consumer can get the datum is if the producer tells him somehow. So in the second case, because the datum is included in the transaction, there's a way for the consumer to find it, and then he can attach it to the transaction when he wants to spend that output. However, that's still super annoying because the way the Cardano node works, the information in the transaction body is, I mean, obviously it needs to be somewhere. So it's like if you run a Cardano node, all these transaction bodies are end up somewhere on your hard drive. That's why it's so big. I said 150 gigabyte, can also be 180 gigabyte by now. So all the historical transactions for the last, I don't know, 5 years or so since Cardano runs they all are on my hard drive and on anybody else's hard drive who runs a Cardano node. But for performance reasons, only the UTXO set is like easily accessible to a node. So that's like kept in probably in memory, or at least somewhere in like an easily accessible form in the node. So the node only has access, quick access to things that are contained in outputs, not in transaction bodies. And that means that even though the information in theory is somewhere on your hard drive, using the Cardano CLI, for example, you can't get it. All you can see is the hash still. So that's like super annoying, I find, because you know the information is there, it's on your hard drive, but there's no way for you, no way I'm aware of, to look it up. So the consumer still would have the same problem. If he wants to spend an output that contains a datum, even though the datum is somewhere there in the blockchain somewhere, there's no easy way for the consumer to look it up. So if you have the Cardano CLI, even though you know somewhere there are these 180 gigabytes of data sitting on your hard drive, and somewhere there is this datum, you can't find it. That was solved by so-called indexers. So IOG had its own indexer, and there are also third-party service providers, like I mentioned before, Blockforce, Maestro. So basically the most valuable service they provide is this so-called datum lookup. So those services, you can give them the hash, and then if the second way was chosen, I mean, if the first way was chosen, they also can't help you, because one of the most important properties of hash functions is that you can't guess the thing that hashed to this value. So it's like one-way function. If you have the value, you can hash it easily, but if you have the hash, you can't reconstruct the value. So in this case, you're just out of luck. But in that case, I mean, what these service providers do, like Blockforce or Maestro, they, whenever they see a transaction, they save the datum in the database and index it with the hash, and then they have the service, you give them a hash and they give you the corresponding datum. So if you use one of those service providers and you want to construct a transaction that spans a script output, I mean output with a datum, then you can ask Blockforce, give Blockforce the datum hash, and Blockforce will answer you with the datum. And then you can use this datum to construct your transaction. So that was like the state of affairs until, I don't know, a year ago or so. And now the most modern version that they should have, in my opinion, like used the whole time and forget about those two, but whatever, is so-called inline datum. So that is now the way it like should anyway be, where the whole datum is attached to the output, not just the hash, the whole datum. And in that case, even the Cardano CLI can show it. And in that case, if you want to consume that, if you create a consuming transaction, you don't even have to give the datum. So you can just say, look it up yourself. And if it's like was attached as an inline datum, then all is good. So that's like the nicest case. However, I mean, to be fair, there are trade-offs here. I mean, this makes it easiest for the consumer, but it also makes it most expensive for the producer, because for transaction fees, you always have to like pay for the size of the transaction. So actually this first way here is the cheapest for the producer, because the hash is relatively small. This one is more expensive, and I think this one is even more expensive for whatever reason. I mean, one should think that this is like the same size, maybe even smaller, because you don't need the hash, but it's not. Somehow I think because outputs are somehow more expensive than bodies. And the reason is exactly this storage thing, because the nodes have to keep the outputs in like memory. Bytes that sit in the output are more expensive than bytes that sit in the body. So this is for the producer the most expensive option, but for the consumer the most convenient one. This one is like, I mean, the consumers still need a third-party provider like an indexer, like Blockforce, Maestro, or you can also run your own indexers. There are also local indexers. One popular one is Kupo, for example. So there are tools that I could run next to my node. I actually do run them next to my node, that can do this indexing for you. So you don't have to use a third-party provider, but you need some additional tool. And in this one, you need to phone that person and ask, hey, what was the datum? Right, yeah, I just wanted to get that out of the way. And then when you construct a transaction, you can specify, with the Cardano CLI, for example, you can specify which of the 3 ways to use for a given datum. And same, if you construct a transaction, consume such an output, you can also specify. I mean, you can attach the datum, or you can say, I don't need to because inline datum was used. So that's a bit annoying, but it's what we have. Okay, so I think the time is up, and that's also done. Are there any last questions? Otherwise, then we can start with actual smart contracts on Wednesday and see first examples of smart contracts.
There are no questions in the chat.
Okay. Then let's end this here.
Oh, we have one question.
Just a thank you, right? No, sorry.
No, someone raised their hand.
Yeah, please go ahead.
Hi, how are you?
I'm good. How are you?
Oh, fine. I joined quite later, so I have to go through all those documents. So
Okay.
apologies for that.
No problem. We have a question?
No, not quite a question, just an apology, and also wanted to follow up on where I could get the videos, but also where I should go. IOG.
Right. I mean, I'm sure Anderson will put the video of this online again, so you can watch what you missed.
Yeah, please.
Sure.
And I just shared the repository as well in the chat.
Thank you, Robertino. Great.
Nice. All right. Thank you so much.
Okay. Very welcome. So yeah. So I mean, this is now a very good point for people that were a bit distressed by Haskell, or that we lost Haskell, to give it another try, because basically you don't need to know much or anything of what happened before. So this is like a fresh start now. And it's hopefully much more practical because we will actually do stuff on the blockchain.
Nice.
Okay. Are there any other questions? Okay, then thank you very much. And we'll continue on Wednesday, and then we will see our first Icon smart contract on Cardano in action. Okay. Thank you. Bye
Thank
for
you,
now.
Lars. Thank you, everyone.
Thanks, Robertino.
Bye-bye.
Thanks, Antonio. Thanks, everyone. Bye.
Bye.